Hello everyone, I'm Jamil De La Paz and welcome to my science class. I am glad to have you again in this session number 3 entitled Subatomic Particles of an Atom Part 2. Let me give you an overview about today's session. We need to talk about our learning objectives for today. We will review our past lesson. I'll be giving you a pretest. We will be discussing about the different ways on how to determine the number of protons, electrons, and neutrons of a neutral atom and a charged atom. And of course, I'll be giving you a short assessment to determine if you were able to achieve our learning goals for today. Our objectives for today. After going through this session, you are expected to determine the number of proton, electron, and neutron in a particular atom. Specifically, you need to determine the number of subatomic particles in a neutral atom, determine the number of electrons, protons, and electrons in positive ions, and determine the number of electrons, protons, and electrons in negative ions. Previously, we discussed that atom is the smallest particle of a matter that is indivisible and indestructible. This idea was given birth by Leucippus and Democritus. We also differentiated atom and molecules. We discovered that atom is made up of single type of element that can exist on its own, while molecule is a combination of two or more atoms. Aside from the nature of atom, we also discussed the different models of this atom. The first model we discussed was Dalton's atomic model. This is the billiard ball model. According to Dalton's atomic model, an atom is hard, dense, and ball-like structure. This billiard ball model was proposed by John Dalton, and John Dalton is also the mind behind the atomic theory. Second is J.J. Thomson's atomic model. This model is also known as the plum pudding model or the raisin bread model. According to this model, electrons are randomly embedded in the positively charged sphere of cloud. It was proposed by J.J. Thomson. However, there are limitations in J.J. Thomson's atomic model, and one of these is it failed to explain the Rutherford's alpha particle scattering experiment. The third atomic model we discussed is Rutherford's atomic model. This model is an improved version of the plum pudding model. During this time, Rutherford was able to discover a hard, dense, cold nucleus. It was proposed by no other than Ernest Rutherford. Like plum pudding model, Rutherford's atomic model have also limitations, and one of these is it failed to explain the arrangement of electrons in an orbit. The fourth atomic model is Bohr's atomic model. This is the planetary model of an atom. According to this model, electrons are moving in fixed orbitals, proposed by Niels Bohr, and one of its limitation is it violates the uncertainty principle. The last model we discuss is the Schrodinger's atomic model. This model is what we call quantum mechanical model. This model is based on quantum mechanics, a fundamental theory, concepts in physics that explain matter in the scale of atom, proposed by no other than Erwin Schrödinger. One thing that is good about Schrodinger's atomic model is he used mathematics to explain the behavior of electrons. So those are the atomic models proposed by these bright scientists. We are so grateful and thankful because of them. We have now a concrete understanding about the behavior of atoms. Let us now proceed to the next part of our session, and that is your pretest. This is to measure how much information you already know about the topic. I would like to request all of you to get your paper and pen ready because you have to answer these questions. I would like also to remind and request all of you to count your correct answers because this will be used later for your assessment. I'll be giving you time to write your answers on your answer sheet. Let us begin. Determine the number of subatomic particles of a neutral or charged atom. Given this table, atom or ion, atomic mass represented by capital Z, atomic number represented by capital A, number of proton, number of electron, number of neutron, and the charge. The first example is Mg. It has atomic mass of 24, 12 protons, 12 neutrons, and 0 charge. First question, what is the total number of electrons? You may now write your answer on your answer sheet. What is the total number of electrons? That is 12. How about is atomic number? Atomic number is 12. How did I get these numbers? Hold on and listen. Second example, bromine ion. Bromine ion has atomic mass of 80 and 35 protons. What is the total number of electrons? The total number of electrons is 36. What is the atomic number? Atomic number is 35. What is the charge of the ion? The charge of the ion is -1. Last, calcium has 18 electrons, 20 neutrons, and a charge of -2. What is the total number of protons? Total number of proton, 20. What is the atomic number? The atomic number is 20. What is the atomic mass? The atomic mass is 40. And that is how we were able to determine the number of subatomic particles of a neutral or charged atom. Are you now excited to know how I got these numbers? Let us proceed. At this moment, we need to study how to determine the number of subatomic particles of a neutral atom. A neutral atom has zero net charge. Yes, you heard it right. A neutral atom has zero net charge. To determine the number of subatomic particles of a neutral atom, you have to take note of these three important things. Number 1. The atomic number of a neutral atom is equal to the number of proton and the number of electron. Therefore, whatever the atomic number of a neutral atom is, that is also the total number of proton and number of electron. If the atomic number is 10, therefore we can say that the total number of proton is also 10 and the number of electron is also 10. Second, to determine the atomic mass of a neutral atom, all you have to do is to add the number of proton and the number of neutron. The concept is atomic mass of a neutral atom is found or concentrated to the center of the atom, which is the nucleus. Yes, 99.9% of the total mass of an atom is concentrated in the nucleus. Third, the number of neutron is equal to the atomic mass subtracted by the number of proton. Let me give you a simple exercise in determining the total number of subatomic particles of a neutral atom. Before anything else, I would like to introduce to you this simple notation. X is the element's symbol, while A is the atomic number written as superscript, and Z is the atomic number written as subscript. Now, let me give you simple exercises to determine the total number of subatomic particles of a neutral atom. Let us examine this table. The periodic symbol, the name of element, atomic number, atomic mass, number of protons, number of electrons, and number of neutrons. First example is K, or potassium, with the given notation. Based on the given notation, potassium has an atomic number of 19 and atomic mass of 39. To complete our table, the atomic number is 19, the atomic mass is 39, the number of protons is 19, number of electrons 19, number of neutrons is 20. If you are about to examine the given example, the atomic number of the element is equal to the number of protons and number of electrons. The atomic mass of the neutral atom is equal to the sum of number of protons and neutrons. Number of protons is 19, number of neutrons is 20. 19 plus 20 is equal to 39. To determine the number of neutrons, all you have to do is to subtract the atomic mass by the number of neutrons. Atomic mass 39, number of protons 19. 39 subtracted by 19 is equal to 20. Please help me answer sample number 2. 13 Al27. The element is aluminum. Based on the given notation, we have to determine the atomic number, number of electrons, and number of neutrons. What is the atomic number of the given element? Did you say 13? I agree. The atomic number is 13. How about the number of electrons? If your answer is 13, very good. Good job. How about the number of neutrons? The number of neutron is 14. The number of neutrons is 14. Let us check. Atomic number is equal to the number of protons and number of electrons. Atomic number 13. Number of protons 13 and number of electrons 13. To determine the atomic mass of a neutral atom, add the number of protons and number of neutrons. Number of protons 13, number of neutrons 14. 13 plus 14 is equal to 27. To check if we have the right number of neutrons, all you have to do is to subtract atomic mass by its number of protons. Atomic mass 27. Number of neutron 13. 27 subtracted by 13 is equal to 14. Let us have the third example. 8O16. What is the number of proton? If your answer is 8, nice. Your answer is correct. How about the atomic number? The correct answer is 8. It seems to really have a good understanding now about determining the number of subatomic particles. Let us proceed. How about the number of electrons? The number of electrons is 8. Correct. How about the number of neutrons? The number of neutrons is 8. And the name of the element O is oxygen. Let us check this table. The atomic number of a neutral atom is equal to the number of neutrons and number of electrons. 8, atomic number 8, number of protons 8, number of electrons 8. To determine the atomic mass, number of protons plus number of neutrons, 8 plus 8 is equal to 16. To check if we have the correct number of neutrons, subtract atomic mass by the number of protons. 16 subtracted by 8 is equal to 8. I am glad you were able to complete our table. Please remember the following notes. Atomic number of a neutral atom is equal to the number of proton and number of electron. Atomic mass of a neutral atom is the sum of the number of protons and number of neutrons. To get the number of neutrons, all you have to do is to subtract atomic mass by the number of its proton. How about determining the number of subatomic particles of a charged atom? Charged atoms are also known as ions. A neutral atom becomes charged if the given neutral atom either gave off or gained certain number of electrons. There are two types of ions. First one is cation, and cations are positively charged ions. It became cation because it released, it donated, it gave off certain number of electrons. So therefore, we can say that the number of proton is greater than the number of electrons. The second type of ion is anion. Anions are negatively charged ions. The main reason why they become an ion because they gained, they accepted, they received certain amount of electron. Then therefore, we can say that the number of protons is lesser than the number of electrons. Cations are more positive, while anions are more negative. Now, let us examine this table. We have here samples of ions, atomic number, atomic mass, number of protons, number of electrons, number of neutrons, and the charge. At this moment, you are allowed to use the periodic table. Using the periodic table, you can check the other properties of these ions such as the atomic number and the atomic mass. The first sample is what we call sodium ion. This is an ion because it either released or gained electron. In this case, sodium ion is a cation because it released certain amount of electron. Now, how can we get the atomic number of this sodium ion? The atomic number is 11. Same principle with identifying and determining the total number of subatomic particles of a neutral atom. Atomic number is equal to the number of protons. We do not change the number of protons of a given atom because the number of protons of an atom is its identity. If you change the number of protons, you change the nature of the element. Sodium has a number of 11 protons, but if you change the number of protons from, for example, from 11 to 10, that is no longer sodium, but neon. In this table, remember that whatever the atomic number of the ion is always the number of its proton. Number of electron is 10. How did you get the number of electron? Since this is cation, the main principle is it released 1 electron. Why 1 electron? As you can see on the notation, the notation says Na positive. It is similar or equivalent to Na positive 1, meaning to say sodium became charged because it released, it donated, it gave off 1 electron. If sodium released 1 electron, then therefore the number of electron will be decreased by 1. That's why you can see in our table now that the number of protons is greater than the number of electrons by 1. That is always the principle if the given ion is cation. The atomic mass is 23. How did you get 23? First, it could be searched in the periodic table of elements, Or you can apply what you have learned in identifying the atomic mass in a neutral atom. And that is to add the number of protons and number of neutrons since they are both given. To determine the atomic mass, all you have to do is to add the number of protons and number of neutrons. 11 plus 12 is equal to 23. To counter-check it, to determine the number of neutrons, all you have to do is to subtract atomic mass by the number of its proton. 23 subtracted by 11 is equal to 12. How about the charge? The charge of this ion is positive 1. Where did you get positive 1? First, you can find it in the notation. Na, positive. It indicates that, or it is similar or equivalent to Na, positive 1. Then if you would like to take a look closer, the number of protons is more than the number of electrons by 1. And proton is positive, electrons is negative. Since the number of protons is greater than electrons by 1, then therefore the charge is positive 1. I hope you have already a clear picture of how to determine or calculate the number of subatomic particles in an ion or charged atom. Let us proceed. This second example is fluoride ion. There's also another way of naming ions, and that will be discussed to you when you go to your next grade level. Fluoride ion, or F negative, has atomic mass of 19 and the number of protons is 9. What is the atomic number? If you are thinking of 9, your answer is correct. Again, the atomic number of an ion is equal to the number of its proton. Since the number of proton is 9, we can say that the atomic number is also 9. How about number of electrons? The number of electrons is 10. How did we get 10? As you can see in our table, fluoride ion is an ion. Therefore, it accepted 1 electron. So, it is logical to say that fluoride ion has greater number of electrons than its number of protons by 1. Since it is an ion, it is only logical to say that the number of electrons is 10. How about the number of neutrons? I agree, the number of neutrons is 10. How did we get 10? All you have to do is to subtract the atomic mass by the number of its proton. 19 subtracted by 9 is equal to 10. How about the charge? The charge is negative 1. Let us analyze why it has a negative charge. First, you can find it in the notation. It says fluoride ion, or F negative. You can also verify your answer by taking a look at the number of protons and number of neutrons. The number of electrons is greater than the number of protons by 1. Since electron is negative, the charge is negative. Since electrons are negative and the number of electrons is greater than the number of protons, the charge is negative. For our last example, we have barium ion or Ba positive 2. What is the atomic number? The atomic number of this element is 56. Where did you get 56? You can refer to your periodic table of elements to determine the atomic number of the given ion or element if it is not given in the table. The atomic number is 56. How about the number of protons? Since you know already that whatever the atomic number of an ion is or element is always the number of its protons. So therefore, the number of protons is 56. As you can see here, the number of protons and number of electrons are not the same. The number of protons is 56 and number of electrons is 54. There are 2 electrons discrepancy. How about the number of neutrons? All you have to do is to subtract the atomic mass by the number of its protons. 137 subtracted by 56 is equal to 81. How about the charge? Correct. The charge is positive 2. Where did you get positive 2? First, you can see it in the notation Ba positive 2. The positive 2 there is the charge. And if you would like to verify your answer, take a look at the number of protons and number of electrons. The number of protons here is greater than the number of electrons. And the difference is 2. Since protons are positive and the number of protons is greater than the number of electrons, then therefore the charge is positive. And that is how we get and determine the number of subatomic particles of a charged atom or ions. At this moment, let me give you your assessment to determine if you were able to achieve our objectives for today. Kindly notify me through GC or through Messenger if you are done watching this session. Again, I am Gemma de la Paz and see you again in my science class.